A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. We know that the reactivity of metals is different. In the past, we used to have a normal phone, right? But with the invention of mobile phone, we started using the mobile phone instead of land phone. That means the mobile phone replaced the ordinary phone. That means a person A is used the land phone B, but with the advent of the mobile phone C, the land phone B was replaced by C. How do we write this? Yes, AB plus C gives AC plus B. That is, C replaced B from A. Things like this can be seen in our chemistry as well. Let's see how. For that, first we have to prepare some copper sulfate solution in a beaker and then dip a zinc rod into it. What can we see? What happened to the color of the copper sulfate solution? Isn't it decolored? Yes. Is there any change in the zinc rod? Yes, the zinc rod can be seen in brown color. Why is it so? We know that there is copper metal in the copper sulfate solution, and zinc is also a metal. Which is more reactive, copper or zinc? Yes, we know that zinc is more reactive than copper. So, the copper is displaced by zinc. Why? High reactivity of zinc compared to copper. Then, what was the color of the copper sulfate solution? Blue, right? This is due to the presence of Cu2 plus ions. That means the blue color of the copper sulfate solution is due to the presence of copper ions in it. And when zinc rod immersed in copper sulfate solution, the copper ions in the solution get deposited at the zinc rod as copper atoms. What is the change? Copper ion converted to copper atoms. Let's see how. Let's look into the equation of that reaction. Copper sulfate plus zinc gives zinc sulfate plus copper. That means the zinc displaced copper and comes in the position of copper. CuSO4 plus Zn gives ZnSO4 plus Cu. Now, let's rewrite this equation in such a way that it also explains the oxidation state of the ions. What is the equation? CuSO4, that means Cu2 plus and SO4 2 minus plus zinc. Here zinc is in the elemental state, so the oxidation state is 0, gives zinc sulfate. In zinc sulfate, zinc is in +2 state, Zn2 plus and SO4 2 minus plus Cu. The oxidation state of Cu here is 0. That means it is in the elemental state, right? Then, in that equation, we can see that some changes happen to each atom. What is the change to zinc? The oxidation state of zinc changes from 0 to +2. That means the oxidation number increases from 0 to +2. How? By donating its 2 electron. When atom donates its electron, it gets positive charge. You know that, right? So, the oxidation number of zinc is increases from 0 to +2. What about copper? What is the equation? Cu2 plus 2 electron gives Cu. That means the copper changes from Cu2 plus to Cu. Copper ion become copper atom. How? By gaining 2 electrons. So, zinc donate 2 electron and copper gain 2 electron. So, copper changes from Cu2 plus to Cu. That means from copper ion to copper atom. How? By gaining 2 electrons. From whom? From zinc, right? So, here zinc undergo oxidation, that means zinc is oxidized, and copper undergo reduction, that means copper is reduced. We know that the losing of electron is oxidation and gaining of electron is reduction. So, zinc undergo oxidation and copper undergo reduction. Here, oxidation and reduction takes place simultaneously, and such reactions are called redox reactions. It is called redox reactions. Here, zinc is the more reactive than copper, and zinc displays copper from its solution, right? Such reactions have a common name, and this type of reactions is called displacement reaction. So, what is displacement reaction? The reaction in which the highly reactive metal displaces the less reactive metal from its salt solution. Here, the highly reactive zinc displaces copper from its salt solution, that is copper sulfate, and highly reactive metal gets oxidized, that means zinc gets oxidized and less reactive metals gets reduced, that is copper gets reduced. And we now know that displacement reactions are redox reactions. Okay. Similarly, even if we put a copper plate in a silver nitrate solution, we can see the silver sticking to the top of the copper. Let's look at the chemical reaction. AgNO3, that means silver nitrate, 2AgNO3 plus Cu gives CuNO3 twice plus 2Ag. Here, the more reactive metal is copper, right? When comparing silver and copper, copper is the most reactive metal than silver. So, copper displaces silver from silver nitrate solution. And copper is the most reactive one when compare copper and silver. So, copper undergo oxidation and silver undergo reduction. So, copper is oxidized and silver is reduced. Let's look at the equations. What is the change happens to copper? Cu gives Cu2 plus 2 electron. Copper atom converted to copper ion by losing its 2 electron. The reaction is oxidation, loss of electron, oxidation. Then, What is the change to silver? 2 Ag plus 2 electron gives 2 Ag. That means silver ion converts to silver atom. How? By accepting 2 electron. Gaining of electron. What is the reaction? Reduction. Okay. So this is about displacement reaction. Then I will ask you a question. Why it is said that the copper sulfate solution should not be kept in an iron vessel? What do you think? There are two metals, copper and iron. Which is more reactive? Yes, iron is more reactive than copper. So, in that case, iron displaces copper from copper sulfate solution and form iron sulfate and copper. That is, CuSO4 plus Fe gives FeSO4 plus Cu. This is why it said that the copper sulfate solution should not be stored in iron vessel. Okay. So, we learnt about displacement reaction. So, now we know that what is displacement reaction and we compared the reactivities of different metals, right? So, there are some other reactions of metals. Let's see them later. Bye bye.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.